Alright guys, this is the third video in the installment of stoichiometry. What we're going to be discussing today is limiting reagent. Okay, so how do you find out limiting reagent? Alright, well, here's a balanced chemical equation, and here is a sample question. So the question reads, if 10.6 grams of calcium reacts with phosphate, 41.4 grams, which reagent will be used up first? Okay, so if you remember from your notes, the limiting reagent, right, is the one that's going to be used up first. That's the one that's going to run out, and that's going to be the one, which one of this, or whichever it is, that's going to dictate how much of this is produced. So what do we do first? Okay, well, in order to find the limiting reagent, the first thing you got to do is you got to find your moles, right? Find your moles. Now, we're given, let's see, 10.6 grams of calcium. Okay, you're going to put that over 1. And we're also given 41.4 grams of phosphate. Okay, you're going to put that over 1. All right. Now, for those of you that don't know this, we know that to go from grams to moles, okay, we first have to use the molar mass. So we know that 1 mole of calcium has a mass of 40 grams of calcium. And we know that 1 mole of phosphate has a mass of 95 grams. 95 grams of phosphate. Okay, now what happens to the grams? Well, in this case, grams cancel, and the only units that are left are moles of phosphate and moles of calcium. Now, for those of you wondering where I got these numbers from, this is the molar mass. You have the mass of 4 oxygens, which is 64, plus 1 phosphate, which is 31, which gives you 95 grams. And this is just the atomic mass of calcium. So the units cancel. We convert from grams to moles. This times this divided by this gives you 0.265 moles. 0.265 moles of calcium. And this gives you 0.435 moles of phosphate. Okay, so that's all we did. We took the given grams, right, and we used the molar mass of each compound or each element, and we were able to go from grams to moles. This is all review. You should know this. Now, because this number is coming from the given grams, this is the amount of moles that we have for this problem. These are the moles that we have for this problem, right? So this is our have. Now, how do we determine which one is going to run out first? Now, the easiest thing to say is like, well, because this one has less moles than this one's going to be the one that runs out first, but that's not always the case, so don't fall into that trap. Okay, there's actually a process you have to do to figure this out. So what I'm going to do is I'm going to pick one. I'm going to pick the top one. I'm going to say 0.265 moles of calcium. Okay, then what I'm going to do is I'm going to use the mole ratio from calcium to phosphate, okay, to determine how much of this compound I actually need, right? So what's the mole ratio? We're going to go back to here. The mole ratio is 3:2, right? So for this problem, I'm going to need 3 moles of calcium for every 2 moles of phosphate, right? What happens to moles of calcium? Moles of calcium cancel, and you're left in moles of phosphate. So this times this divided by this. Let's see. 0.265 times 2. Divide that by 3. I ended up with 0.176 moles of phosphate. Now, because this calculation is a stoichiometric problem, these are the moles that we should need for the reaction to completely run. Okay, so here's the difference. Okay, here we have moles of phosphate, here we have moles of phosphate. The difference is these are moles that you have based on these grams. And this stoichiometric calculation where you use the mole ratio of the 2 reagents, this tells you how many moles of this compound you need. Okay, so now let's compare the two. I have 0.435 moles of phosphate. Okay, this stoichiometric problem told me that I need 0.176 moles of phosphate. This is what I need, and this is what I have, right? Now, you look at these two values and you say, okay, do I have more or do I have less than what I need? Well, in this case, I have more than what I need, right? This number is bigger. So because I have more than what I need, okay, this reagent ends up being my excess, okay? If this guy is the excess, then this one has to be the limiting, right? Now, you can double check yourself. Always double check yourself. Let's start with 0.435 moles of phosphate this time. I'm going to do the same stoichiometric calculation from phosphate to calcium. Now, from this reaction, I see that I need 2 moles of phosphate, see, mole ratio, 2, to 3 moles of calcium. See, the 3 is right there, 3 over 2. But I set it up in moles that I want over moles that I have. So the moles that I have cancel out, right? Mole ratio. This times this divided by this, 0.435, times 3 divided by 2 gives me 0.652. 2 moles of calcium, right? So again, because this is a stoichiometric calculation, this is telling me how many moles I need. Moles of calcium, see? So I have the moles of calcium that I need and the moles of calcium that I have. So let's compare. I have 0.265 moles of calcium. However, I need 0.652 moles of calcium. So this is what I need, and this is what I have. Now, do I have less or more than what I need? Well, if you look here, this number is bigger, right? Which means I need more than what I have. So since this one is bigger, that means that I have less moles than what I need. So because I have less moles than what I need, right, to run this reaction, this is going to be the one that runs out first. And yes, according to this, it does prove correct. This, in fact, is my limiting reagent. See, because I have less than what I need. All right, so there's the basic process of finding limiting reagent. If you have any questions, let me know.